Alrighty, hello. Today we are going to be taking a look at two different ways to increment a variable in C. The first way is called the pre-increment and the second way is called the post-increment. Okay, let's take a look at what each of these look like and how to implement them. So we've got a little bit of a C program in front of us, right? And we can see in the top right that that's what the pre-increment and post-increment actually look like. Okay, so here's the C program. You've got your standard input output included at the top, right? You've got a couple of prototypes which are for the sub functions that we're going to call in a minute, right? But before we do that, let's step into our main function, right? So that's something you should be familiar with by now, right? Creating a main in your C files. Okay. The first thing we've got is just a print statement to show where the pre-increments are actually going to be. Then we go and we call that pre-increment sub function, and that's where the magic really lies. And then we do the same thing for the post increments. Okay, so let's actually go and step into this pre-increment function first, right? And here we will see that this is actually a while loop, which is being run 5 times. Okay, so what's happening at the top of that is we are setting the variable I equal to 0. Okay, and then we're going to print out the value of I, but we do that after having the pre-increment operator act on it. Okay, so what that means is just before the print function is allowed to use that value of I, it gets incremented by 1, right? So instead of expecting 0 to be outputted, we're actually expecting to see 1. Okay, now moving over to the post increment, we've got a similar setup here, right? But now, because it's a post increment, what's going to happen is that this is going to allow the printf function to use the value of I, and then after this, it's going to increment it by 1. Okay, so remember here, it has been set to 0, right? The post increment is going to allow the print function to use it at I is equal to 0, but after it's been used, then it's going to increment it by 1. Okay, and so let's go and take a look at what this actually means, right? When we take a look at the program execution. So at the top, you can see that I've compiled it with GCC, and then I've run the binary, right? And out pops out pre-increments 1, 2, 3, 4, 5, which is exactly what we were expecting because the value of I was set to 0, but before the print function was allowed to use it, it got incremented by 1. So hence 1 and then 2 and then 3 and 4, right? But with the post increment, it's a little bit different now because the value of I was set to 0. Since it's a post increment, the print function is allowed to use that value. And then after it's been used, then it gets incremented by 1, right? Hence the 0, 1, 2, 3, 4. Okay. All right. Let's go back into our C file here and let's actually take a look at, what the point of all of this is. Okay. So usually we increment, a variable by 1 by simply saying I is equal to I plus 1. Okay, and now look, that works fine when you've got like small expressions such as I, right? But when you increase the complexity to something like x divided by y minus z plus 17, right? All of a sudden you've got to write that expression on the left hand side and then equals to, and then you've got to get the same expression on the right hand side. And if you make a typo, now you're a bit stuffed, right? And then the plus 1 on the end. Okay, as well as that, looking at that, that's impossible to read. Okay, and creating code that's easy to read is always a priority for a programmer. Okay, so yeah, look, natural, easier to increment complex expression and code that's easier to read. There we go. Okay, now all of this source code, this can actually be found on either the public HTML site that the uni provides, or you guys can check this stuff out on GitHub. Okay, but yeah, look, that is pre-increment and post-increment. All right, thank you.